Okay, welcome back to CyberBee. This is the channel where I share what I learn in cybersecurity as I go. And today we're jumping back into Let's Defend to finish off this current lesson. So where are we at right now? We're at detecting web attacks. Okay, and we are on we're on this one, cross-site scripting, I believe. Yes, okay. Here we go. So unfortunately, I was recording this and then I was typing in the answers into some of the questions down below as we usually do, and I didn't know, but some of those keys actually stopped recording. And so I went halfway through. That's why I finished off these two, and you see that the last two are still yet to be completed. And now we're going back at it again because I want you guys to learn with me. So let's get to it. Cross-site scripting, also known as XSS. So what is it? It is a type of injection-based web security vulnerability, it says so right here, that can be incorporated into legit web applications, allowing malicious code to be executed. So what does that mean? It means, actually, it brings you down to it. It means basically when you go onto a web page, or web application actually, and it allows the user to enter anything in the field, bad things can happen. That's essentially what it means. So today, most frameworks are used to develop web apps have taken preventative measures against XSS attacks. However, we still see vulnerabilities today because some frameworks are not followed, or they're not used correctly, or the framework itself has vulnerabilities built into it, and that the data coming from the user is not sanitized. You'll see that this is a very common or like central theme in everything to do with web apps. So make sure, if you like take anything away, make sure user data is sanitized, okay? So there are three types of cross-site scripting. One is reflected, so non-persistent, meaning it's a one-time thing. So the payload must be present in the request. This is the most common type. Okay. There's second is stored, which is persistent, which means it's perpetually there. So this is where the attacker can permanently upload the payload to the web app. So compared to the other types, this one is the most dangerous. And self-explanatory, naturally, that's why, because it can permanently be uploaded. Okay, third is DOM based. Okay, so this I remember when we were studying for Sec Plus, I was a little bit confused on as well. So let me just start a new ChatGPT and ask them, because they don't really go into. Okay, so DOM is Document Object Model cross-site scripting. It's a type of client side, so only on the client side, not on the server side. Vulnerability, where the malicious scripts are executed in the browser due to improper handling of untrusted data in the DOM. So basically, it's the environment in which the client can pull up the web app. That's kind of my understanding of it. Okay, so if you, feel free to read all this and punch it into your own ChatGPT if you want to read more into it, but that's kind of all the information that I need right now. So DOM-based XSS is an attack where the payload is executed as a result of modifying the DOM environment in the victim's browser, okay, used by the original client-side script so that the client-side code runs in an unexpected manner. This is the source is OWASP for that definition. Okay, so getting to the meat and potatoes. How does cross-site scripting work? Okay, so it's a vulnerability that is caused by the lack of data sanitation. Once again, right? Central theme. It has occurred when the data received from the user is sent in the response without being sanitized. Sanitized just means like double checked, basically, right? Maybe they have a set of patterns or acceptable requests or something like that that it needs to fit within, but because you don't have those boundaries, anything goes, and that's what makes it dangerous. So here's an example. It says open paragraph, hello, and then it's got this PHP echo $get user, and then whatever you put in this parameter, you can get, right? Close paragraph. So That's exactly what I said. It simply displays whatever is entered in the user parameter. So if we enter let's defend as the user parameter, we will see the words hello, let's defend. Pretty harmless, right? No problem so far. So when we, encounter issues is when, so what would happen if we didn't enter a normal value and instead a payload that would trigger a pop-up. So it'd be something like this: script alert 1 close script, and this triggers a pop-up, right? So maybe instead of a pop-up, it's something actually a lot more malicious, right? So that's how cross-site scripting works. Because the value entered by the user is not validated, the attacker can enter any JavaScript code, okay, and get the result that they want. So what if the attacker wants to redirect the user to a malicious site? You can go script window.location equals whatever URL, close script. So it could look something like this. Do you see how like the URL is just very, so obviously this is normal. This is a dead giveaway, XSS, cross-site scripting example, PHP. And then it's got like user equals, all these percentage signs. We know that they mean something. Script window.location equals sending us to Google, close script, all this stuff. So if you recall in the SQL injection, we were also searching for the percentage sign in the web server log for us to find the attack when it was happening. Okay. So of course they're not going to redirect you to a web app, but directing you to Google would be sufficient as an example. Yep, that makes sense. Okay, so how attackers take advantage of XSS attacks. Okay, so what do? They can steal a user's session information, they can capture credentials, etc. So, I mean, these two are already quite dangerous. You don't really know what they're doing with that information, right? Why are they stealing your user session info? Capturing credentials, obviously your logins, depending on what web application you're using. Maybe you're doing online banking, maybe you're looking at your crypto, maybe you're, I don't know, doing some investment. So like that's kind of where that impact would come. So how do we prevent vulnerability? Number one, sanitize data coming from a user. Use a framework, use it correctly, and keep your framework up to date. Okay, so detecting it, yes, here is the goal that we're looking for. Is one of the most commonly tested vulnerabilities, and you will encounter it throughout your career as a SOC analyst. So, number one, look for keywords. This is the easiest way to detect attacks, is to look for keywords like alert and script that are commonly used. Okay, learn about commonly used payloads. Okay, so here's a website that they gave us that we can look at in a little bit. Okay, so yes, of course, that makes sense. Familiarizing yourself with commonly used payloads would make it easier for you to detect cross-site scripting vulnerabilities, of course. Okay, lastly, check for the use of special characters. So, okay, check data coming from a user to see if any special characters commonly used in payloads. Okay, such as greater than, less than are present. Okay, so I just said earlier, right, the percentage sign, let me just go back to this, percentage sign, okay, equal sign. I don't actually see it, it's like, oh, that's what they're saying, greater than, equal than, because of that. Okay. Okay, so those are good to know. And then here's an example. Okay, it's really tiny. Okay, so what it's saying, let me just make this bigger. Oops, hello. Okay, what it's saying is in this web access log, we can see that it's requesting get on this page, like blog page. And then as you can see, it's question mark s equals, and all these different things are just different. So you know that they're kind of probing right now. And looking at the timestamp here, February 19th, 2022, so 6:25 p.m. And this whole thing is within 30 seconds of each other. So that's not humanly possible, right? And we can also see that these IP addresses, they are changing every, I don't know, 5 to 10 tries or something like that. Here's like, maybe this one's legit, we don't know. So this is like, the 140 and then changes to 160 once and then 36 and then goes back to 162. Interesting. Okay, 36 again, 140 again, 36, and then this 52, 2021. Sorry, 221, which is the same as the top here. So it's probably some sort of script or software or something that is doing this. So that's what I can tell by just kind of looking at this. And again, like some of the how to tell if you're, getting attacked, it's on here, right? So here's a percentage. Oops, right, this is an image. Here's a, I can't highlight here. Here's a percentage sign, right? It's like a weird kind of thing. Here's a word script in it. These two are probably, might be okay. That's why it's 200 possibly. This is interesting. I don't really know what the Python URL library is for. I'll have to ask AI that. And it's a pattern, right? So it's like that HTTP 1.1 and then script, HTTP 1.1, script, HTTP 1.1, script. So they're trying something. They're trying to probe for something, or they're trying to like get into something. You can tell that. Okay, so let's see what it says below and see if I missed anything here. Okay, so it says blog page with the S perimeter always changing. Okay, it's difficult to find examples that are easy to read. Absolutely. So look, we see characters that have been converted to the percentage sign XX as a result of URL encoding. We'll do URL encoding next. Great, because I don't know what that is. Let's look at the URLs and see if we can spot any words. Looking at the logs, okay. Well, I think this and this is the same thing. Why did they have to change it to a different background? I don't know. Okay. Looking at the logs, there are JavaScript related words like script prompt console.log. Okay, the word JavaScript immediately brings cross-site scripting to mind. If we encode the URL, we can easily understand the requests being made. Okay, I can only just take it at what they're saying right now. Okay, let's take another look at the access logs after decoding the URLs. You can clearly see that the payloads and definitely conclude that the WordPress application from which we receive these access logs have been the victim of an attack. When we examine the requested IP, okay, we find out there's more than one, right? So these IPs down here. Okay. Is there more than one attacker trying to perform an attack at the same time? Or is the attacker constantly changing their IP to avoid being blocked by firewalls and IPSs? I think it's that. If you check the IP address, you will see that it belongs to Cloudflare. Okay, so I guess this is more of an external thing where you can go to some sort of like IP checker and see where it belongs to. Okay, so we can do that in our lab. So since WordPress has a partnership with Cloudflare, it's normal that it would be the source of the request. Okay, so all of these belong to Cloudflare, so it doesn't give us that much more information, but it's good to check. So now we look at the dates of the requests, and we can see that a request was made every 3 to 4 seconds. Not possible for a human to enter that many payloads in a short time, but it still doesn't mean you can be sure that the number of requests made per second is excessive. Okay, so we don't know that because we need to have some sort of a baseline, right? Because what if that page is very popular? Because we have the user agent information in this example, our job is easier. I don't see where they have the user agent info. Like, where do you see that? Or maybe you need to right click and get more info, but we can't do that because these are images. Okay. Filing that at the back of our brain. Once we check the info, we see that it belongs to a URL lib library. This indicates that these requests were made by an automated, vulnerability scanner tool. That's this thing, the Python, because I don't know what that is, but yeah, another thing to Google or ask ChatGPT. Interesting. So cancel, so we got the script there, and then cancel.log is also another signal that it might be an attack. Okay. This indicates that these requests by me. Okay, cool. Read that. Was the attack successful? Without access to the responses, we cannot be sure. So as a result of can't talk. As a result of our investigations, it is clear that the attack was aimed at the web application where the access logs came from. Yes, okay, that made sense. It seems so like obvious, so I don't know why they're stating it. Anyways, looking at the number of requests and the user agent info, we determined that the attack was carried out by an automated vulnerability scanner. Okay, so I did come to the conclusion that this was not humanly possible, so it must be some sort of script or something. I just didn't know that this URL lib library was a software. Let me just quickly URL handling modules. It's a package that collects several modules working with this. It's for opening and reading URLs. That doesn't give me that much more information. Okay, okay, coming back to this. As the application is hosted behind Cloudflare, the source IP were not found. We do not know if the attack was successful or not. Okay, so I'm waiting for it to load. And meanwhile, let's go back to this list of payloads that they linked out to us. So, okay, here are some vulnerability scanner tools. Okay, they're all GitHub, except for this one, XSS Scanner Online. Let's just open that up, see what it's like. So, okay, so all of these are payloads that they accumulated over time. So we can see prompt, okay, is a pattern, one error or on error, JavaScript, script, alert. Okay. I mean, there's definitely some patterns here that you see over and over and over again, right? So when we're in the lab, I'm going to Control F and try to see if I can find some of these ones. That might be able to help me locate what's happening when and by whom. This is really long. Look at that. Like my thing is. Okay, so I've got what I needed for now. Scanner. Interesting. Get and post scan. Cool. I'm not going to put stuff in there right now. 27%. Okay, why don't we just go over some of the questions right now so that when it loads, we're ready. Okay, so so the first question is typically, what is the start date of the cross-site scripting attack? Okay, so I was able to find this. What is the IP of the attacker who's performing the attack? Okay, was it successful? And then lastly, what is the type of cross-site scripting attack? Okay, so we're gonna find all that once this is done loading. Okay, let's go on to the next one then. So detecting command injection attacks. Okay, command injection attacks are attacks that occur when data received from a user is not sanitized. Again, central theme here, and is passed directly into the operating system shell. So I'm not really understanding why this has so many typos in it. RM, RF injection, okay. So since the attacker's priority is to take control of the system, these vulnerabilities are more critical than other vulnerabilities. Okay, a misconfigured web app would grant the attacker access with admin rights because the command of the attacker uses the rights of the web app user. Okay, so how does the command injection work? Okay, when the data received from the user is not sanitized. All right. Okay, so suppose we have a basic web app that copies a user's file to the temporary folder. The web application code is shown as such. Okay, PHP file name equals post file name, output equals shell execute, copy file name temporary. Okay. Under normal circumstances, if used correctly, the application would work normally. For example, if we upload a file called let'sdefend.txt, it will successfully copy the file to the temporary folder. So what if we upload a file called let'sdefend, list, dot text? The command would be copy let'sdefend and all that, right? So the colon or semicolon indicates that the command has ended. Okay, so if we look at the payload above, there are three different commands, right, that the operating system executes. These are copy, let'sdefend, list, and then .text. That's not a command though, that's confusing to me. Anyways, So that's what it's gonna write. C dot text command not found because it's not a command. So first it's copying this first thing. So copy, it's missing destination file operand after let's defend. Try that for more info. Okay. The first command is the copying process, but the parameters were not entered correctly, so it will not work. Okay. The second one, ooh, there you go. Okay, let's just finish this off and then we'll go back to the lab, okay? Sorry, I lost my train of thought. Command 2 is the directory listing command, right, that the attacker wants to execute. The user does not receive the command output, so the attacker cannot see the files in the directory. Okay, but the OS successfully executes the command. Interesting. So if the OS tries to run command number 3, it will get an error because that is not a command. As you can see, the code has been executed in the web server's OS. So what if the attacker were to upload a file called let's defend shutdown.txt? The OS would shut down and the web app would not be able to function. With the correct payload, the attacker can create a reverse shell in the operating system. Reverse shell is basically when the attacker has infiltrated the system and it has basically set up a link, typically a backdoor or some sort of remote control type thing, access into a particular system or device or endpoint so that it can come back and do more damage whenever they want. That's my basic understanding of it. So how attackers can exploit command injection attacks? Okay, that didn't tell me anything. How to prevent, always sanitize, right? Limit user privileges. Okay, that's just best practices. Basically, set the web app user rights at a lower level or the lowest level. So few web apps require users to have admin rights. Very true. And then use virtualization technologies such as Dockers. Okay. Instead of giving them access to a real thing. Yeah, okay. So detecting. This is where I'm most curious about. So don't know if you guys feel the same. So how do we detect command injection attacks? Okay. So one, when examining a web request, look at all the areas. Okay, might be in different areas depending on how the web app works. Therefore, you should check all areas. Okay, this is pretty vague. Like, what are the specific areas? What are all the different areas? Okay, second, look for keywords related to terminal language. Okay, so commands. When talking to your terminal commands, like directory, list, copy, concatenate. Isn't it concatenate? Learn about commonly used command injection payloads. So when attackers discover a command injection vulnerability, they typically use a reverse shell to make their work easier. Knowing commonly used injection payloads will make it easier to detect. Okay, so last time they linked out to a resource and this time they didn't, so we might have to Google that ourselves. All right, so here's an example. In this example, we will not be looking at access log, but instead at an HTTP request. Okay, so I wonder if all command injections are this instead of access logs? I don't think so though. So okay, get HTTP 1.1. Host is yourcompany.com. User agent, this is weird. I don't know what that means. Okay, accept text, accept, this is also kind of weird. Text, HTML. Okay, just a bunch of stuff that I don't really, okay. Accept encoding, gzip deflate, accept language, English in the US. What does Q equals 0.9 mean? Connection closed. Okay, so what are we looking at here? If we look at the HTTP request headers, HTTP request headers, we see a suspicious situation in the user agent header. Okay, yeah, that's what I'm saying. It looks weird. There is a bash command in the user agent header when there should be browsing operating system information. In fact, this request was captured when a security vulnerability called shell shock was being exploited. Shell shock is a security vulnerability that was disclosed in 2014 and had a major impact. Okay, shell shock comes from bash, somehow executing environment variables unintentionally. Okay, contents of the file, etc. password are returned to the attacker as NS. I was wondering what that meant. name server, or just like gibberish, like space holder, text in the HTTP request header. I say that weird. I'm just listening to myself. Header. When the bash command, which is in the user agent, is executed. Okay. So I think the dead giveaway was this, which I gawked at, but I didn't know why. But here we go. Now we do. Okay, lab environment. All right, so let's go back to cross-site scripting. Let's enter this. Okay, great. So I know, I'll just take you guys down to here. It says here, root desktop question files, XSS web attacks, and then the password file is access. So let's just go ahead and do that. Open Sesame. Come on. Okay. And I'm going to go hide this, make more room. That is not the big as it can be, is it? I guess so. Okay. So this is the access log that we're looking at. I don't like this, so I'm going to move it into new tab. So we will have the questions here. So what is the start date of the attack? And then what's the IP? Okay, so I think what I did, I'm trying to retrace my steps here, is control find equals, I'm just like searching up those key phrases and whatnot that they told us about in the lesson. So I don't really see anything here that's too whatever. Script. Okay, there's a few scripts here. Lines 185. Okay, oops. I'm just keeping that in the back of my mind. Alert, which is also 185. Okay, so my guess is it's here. Oh. You see here it says vulnerabilities, XSS _R. Okay, name equals, question mark name equals, and then all these weird percentage stuff. There's script, there's alert, there's script again. So I'm betting that this, remember how I entered the less than and equal then, and it didn't come up with anything? It's because it got encoded, or whatever the right word is, into these special character things, right? So I bet you that this means open bracket, like the less than, and then greater than, alert, and then there's, I don't know what that is. And then, yeah, there we go again. So less than, slash, backslash, and then close bracket. So I believe we found, what is the rest of this? Okay, so that's fine. I believe it's this. So March 1st, 2022, 085320. And then the IP is this, 192.168.31.138. That's correct. Did it say 20? Yep, I did. So that's correct. And then was it successful? I was guessing at this. I said yes and it was right. And then it said what type. And also you can tell that it was successful because it asked you what type it was. So reflected. And how I got that was up here it says vulnerabilities / XSS _R, and R I assumed stood for reflected. So that's how I got that. Okay, so let's go to the lab. Oops, let's go to lab here. It's the same lab, so we're going to exit out of here, exit out of here. This is the command injection one. I'm sure the password is the same. Okay, so let's see if I can open this up on just like bigger in a new tab and where you can see my mouse. You can, okay, cool. So what are the questions? I'm sure it's the same. And this one is only 3, great. So what is the date of the attack? What is the date the attack was initiated? What is the IP of the attacker? And then was it successful or not? Okay, so for this one, what did we learn? This one was like terminal language. It wasn't like scripts or alerts or even percentage signs. But let me just show you. It's like there's nothing there. Greater than, nothing. No. Script, nothing. Alert, nothing. How about equal? There's a few, but it doesn't look like it's that bad. So what was the thing? Directory. There's a few here. I bet you it's that. What was, just want to show you. List. There's another two. What was it? Copy, I think. Copying. Sorry, cat. Oops, cat. Type. There was another one I can't remember, but let's go back to ls or directory or something like that. Okay. So from this, what do we see? Okay, so another one that I'm seeing as a pattern is vulnerabilities. Vulnerabilities. There's 19 of them. Okay, look at all this. Is this before or after? Oops, oops, oops. Go up. Okay, this is where we were because this is where list and directory is. So line 210. I'm starting at there just because it has this vulnerability in the page that they're trying to go to. I entered this. It said that I was close, so not quite there. And I think I know why, because this can seem kind of normal-ish. It doesn't have the terminal commands in there, even this one. So I started here, Q equals that. No, so I started here because remember there's like, this is all a command, the colon, semicolon, something else, da 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 da, and that's kind of the sign, one of the signs that they gave us. And this is where it starts becoming post. So I believe I put this. Okay, so March 1st, 2022, 9 a.m., 3 minutes, 33 seconds. And then the IP is 192.168.31.156, which is correct. 33 seconds. Great. And was it successful? It was actually really hard for me to figure it out. It was not successful, and I think this is the reason why. So when you get down to here, so as you can see, this is all the same IPs, and then it suddenly switched it to 200. And here it's still kind of, it's back to get now. It's still trying to probe because this has been coming up for quite a while now. Right, 200, 200, 200, it's all down. So there's that, which is not a very strong argument. But also, if this IP got into it, if they were successful, they wouldn't be switching IPs. They would just be in there doing their thing, whatever they want to be doing. So there would be no need to switch. That's also one of my logics. Could be wrong, but even looking at this get, it doesn't have anything super fishy in it like these ones that we were looking at, right? So the list, who am I, directory, list again with the double ampersands. Even password is here, and then afterwards it's not post anymore, it's get. It's back to get. Let me, oops, post 15. Okay, so those are kind of far and few between, unlike this one where it's like post, 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 post. Okay, so I guess that's also another term that we can search when we're doing this. Okay, next one.